All right. So first of all, variables names. All right. So we have a lot of ways to name variables. They are all case sensitive. All right. And the first character must be a letter. Okay. You cannot start with a number. So yeah, you can use uppercase or lowercase, and those are different variables if you do so. Obviously, you don't want to make two names. The only difference is like one that has a letter uppercase, one the letter lowercase. That will confuse a bunch of people. Usually for variable, you will like for the variable you want to change after, you will use all lowercase. All right. And if for a constant value, you choose all uppercase. That's just convention, so people knowing what you're trying to do. So for example, if you're having a variable called word length, right? So word underscore length, that could be your name. Like in Python and other language, sometimes you want to make your variable a bit shorter by avoiding having the over underscore. So starting the second word, you can have the first letter capitalized, like word, no underscore, just length, but the L is upper score. Yeah, so that's make it more readable. So older version of C, they have some requirements such as the first 8 character of your name should be unique, so the compiler will know they're different variables. But nowadays, this requirement has been changed, it's been extended, so they will sometimes say a first 30 characters. So that's basically give you all the freedom. You can just name your whatever your variable is what you want. But keep in mind now, like, because the compiler does take the beginning portion of your variable name to determine if they're the same thing or not. So if you want to make a very long variable name, make the from part be unique. It's also for readability, right? Like if you're reading that just as a human, you want to figure out if they're the same variable or not. Yes, such as the other language, we also have those reserved keywords such as if, else, integer, float. That's quite obvious. All right, move on to the data type. So those data type we have talked about last time, right? Character, integer, float, and double, right? So the double is just like double precision of float. So it's using more bits to represent a floating point number. Here, a few things. So those are not necessarily called a type, but they are more like a qualifier for the integer. So if you have C, like a new variable called short x, that's actually an alternative form as short integer x. So it's an alternative version of the integer, as well as the long and unsigned version of it. So often the integer in this case will be omitted, so you will only see the declaration or the declaration of short x, not have the integer in between in real code. But here you just to see the complete form for your understanding. So that's again, this is not called a basic type. They're not basic types. They're like the qualifier for the integer type. All right, so the difference between those are using different data bits to represent a character. The idea is we also always want to save the memory, right? So if we know your integer is pretty short, so we will use this one. So it only takes 16-bit versus the typical integer will take 32-bit, or long will take even more, right? So basically just choose the right one for you, for your purpose. So just talk about those choose of integers. So it's always you will have to pick one, and you will regret later because you will never know how long you will need to use those software for. For example, in the initial Unix system, which is they decide use integer for representing the date. Obviously, that makes sense. So the starting of the day is 1970, when they designed this software, or actually a little bit after that. But then at the time, they believe, oh, 32-bit is more than enough, because that could be used until 2038. But now it's actually approaching, if you consider it now, right? It's only 14 years away. We're still using this system. Like when you design the system, you must see, oh, okay, just like this software might be used for another year. That's it. But I already have 32-bit. Turns out, because more and more software are append on that, it's very hard to make the change. Yeah, but I think this problem has already been solved, as far as I hear from the news. But just give you an example. All right. The other thing is the constraints. So, like for example, okay, so the long integer constraints are written with a L suffix, so such as like whatever numbers and L. So that tells you it will be stored in a long integer form, all right, rather than a regular integer. Also, you can assign those floating point using the scientific notation, using the E in between. You can use it. The compiler will understand that. All right. The other notation, okay, is for octal number, which is the base of 8, right? The number with base of 8, we will know that with a number 0 at the beginning. All right. So can anyone know what's this? How to convert this 037 to 31 in decimal?
Multiply by 2 to
So
the
I
power of
have. Sorry.
Multiply by 2 to the power of 8. 1 and 2 to the power of
Multiply that
8
by
too.
8. Oh, every digit. Yeah. Yes. Okay. So one way is that you multiply each digit, like this last digit 7, multiplied it by a to the power of 0, right? And the second digit is multiplied by a to the power of 1, and last digit is a to the power of 2, right? So here we only deal with a to the power of 1 times 3, right? So that's 24 plus 7, right? So that's 31. Okay, this is one way. Does anyone know how to convert that into binary instead? Octagonal front. To keep dividing? Well, yes, if you converting from decimal to binary, yes, you keep dividing. For octal, it's easier because every bit will convert to 3 bits, right? Every octal bit will become 3 bits, right? So such as 7 is 111, right? 0 means 000, 1 is 001, right? So on and so forth. So 3 is, I believe that's 011, I believe. I might be wrong, but yeah. So anyway, the point here is every octal bit will be converting to 3 binary bits, right? So that's actually very convenient. That's why we often use that in this C, as well as hexadecimal, right? So it's base of 16, right? In that case, every bit will be converting to 4 binary bits. Right? Okay, again, this is a little bit complicated, but hopefully you already learned that beforehand. So, yeah, the hexadecimal is starting with 0x, either lowercase or uppercase, doesn't matter. It's all present as hexadecimal. So again, be very careful about this here. If you see a number starting with a 0, it must be, okay, octal, right? If it's a 0x, that's usually more obvious. That's hexadecimal. All right. Move on. All right. Here are a few non-printable characters, right? That's means you cannot see those characters on the terminal, but those are very useful ones, such as new line tab, new character. Okay, again, when we're going to use this new character? One example. Still remember last time? No. What kind of
To remove the percentage sign.
sorry, percentage?
Yeah, we get percentage sign, right? So to remove it.
Maybe not that one. We have talked about saving string in our array. Remember? So in C, there's no type for called string, right? We basically store the string in an array of characters, right? So last spot in your array need to be this new character /0. So your program knows, oh, that's the end of the string. All right, so that's what you will use for. And if you're going to use the backslash itself, you have to use double backslash. So it will show up correctly, or the single quote. All right, you can do that as well. Note that those are only take one character. Okay, although you can see it's slash and n, it seems like two character, but in C, it believe that is like one character. Okay, that's to be very careful. Let's say if you're reading a string with a /t in between, that's only take one character length. All right. All right. The other thing is this using this slash 3 digits here. Those are to represent some special characters. So those characters could be converted into some special symbols based off ASCII code. Here, 3 digits are all in octuple digits, but we're not usually use them in our class here. All right, string constraint, as I just mentioned. First of all, we always quote our string with double quotation, right? If it's a one character, it's a single quotation. If it's a string, double quotation. All right. In that sense, if I have a string, sorry, let me see if I have the example here. For example, here, I have a character called x between the single string, a single quote. This is not the same as the same x between the double quote, right? Because the later case actually have two characters. One is x itself. The next one is a new symbol. All right, it actually contains two. So we'll just use this array as input, and we doing the while loop until the character is the new character, right? That's the end of the string. Until we meet this number, we will keep adding 1 to our counter. So then we will return this number at the end. Okay, declare. When we declare a variable, we have multiple ways. Like this way, this example here, we declare more than one variable at a time on one line, right? So you can, as long as they're the same type of it. One thing is you can declare the character as well as the array in the same type on the same line. So that's something you could do. This is the alternative way, right? So this way, it's taking more lines, right? You basically break it out. But the benefit is it gives you space for comments, right? So you can add comments to explain what each means. You could also assign value while you're declaring this variable. That's very convenient. but depends on where you use it, I guess. All right, so there are two steps. One step is called initialization of the variable, where you declare it, say integer x, to declare it. It will be initialized when program like just start when, during the program starts. While the automatic variable, which is the variable you pass into your function as argument, those will be initialized every time the function is called, right? Because every time a function is called, we're going to create a new copy of those variables, remember? So that's why they're initialized every time it is called. So by default, if there's no value assigned to the variable, by default, the external and static variable are initialized to 0 by default, while the automatic variable, which is the variable used in the function argument, are undefined value. Undefined value basically just being assigned to a random space in the memory. It might have contain any information there. So that could cause a lot of problem if it's not done properly, but usually it's fine, right? Because you're passing this argument into a function, so it should have some value being assigned anyway. Okay, some operators: addition, extraction, manipulation, modulus, right? So the modulus is something different from our math class, but otherwise everything else is the same. Unary sign, right? This minus sign could do two dual purpose, either as subtraction or unary sign, right? For negative value, right? All right, for example, we can use this function to calculate the leap year, right? So that's basically follow the logic. If it's modulus of the year by 4 equals to 0, and modulus by 100 not equal to 0, and other requirements here. So this symbol here, the modulus symbol, can not apply to floating point because we're talking about the remaining part of the division, right? So then it makes sense if you do that on a floating point. So just means usually you just only do that on integers. Yeah, so when you are evaluating an equation, okay, the unary minus sign will be evaluated first. So the compiler will process those first, followed by manipulation, division, and modulus. And finally, it will process the addition and the subtraction. So this is the order from top down, left to right, right? So that's the order. Again, usually if you're going to do that, you want to use parentheses to brackets to make it more readable. One thing, all right, so if you're adding three numbers together, a plus b plus c, sometimes even you add the brackets, say around b and c, the compiler will actually make a decision to say, okay, it's more efficient for itself to process a plus b first, then to plus c. It might happen, right? So even you explicitly says, I want c and b and c be added together first before be added to a, the compiler might choose the other way around. Okay, that's something you have to be very careful about. Well, in practice, not in our exam, not be, but that's some like compiler feature. The compiler will make some decision based off what's the most efficient way. All right. One way to work around is there's some tag you can flag, say, tell the compiler do not optimize my code, like in that line specifically. That's one way. The other way is even simpler. You just assign a temporary value first, right? So you do not create an equation like this. You rather say E equals B plus C, then you add E to A, right? Something like that. Yeah. Personally, I don't like have a very long equation because that's very hard for you debugging. You have three numbers adding together, it's blown up. All right, then you don't know which one of the three causing this problem, right? So always a good idea to break them up. All right. Relational and logical operators. So for relational operators, those are for comparing values. Greater, equal, small, less than or equal. The equality comparison is equal and not equal, right? Equal is double equal sign. Not equal with the mark at the beginning. All right. So the relational operator, those comparison sign, having a lower precedence than the previous operator like those, but it's higher than the logical operator. Okay, the logical operator are here. So they are and or not. So those are combine the logic between other expressions. So let's take a look at the example here. So I have a for loop here. The most important part is in the middle. All right. So I have comparing three things. First part is I should be smaller than lim minus 1, right? So this is the first comparison. The second comparison is the character shouldn't be the end of the line, right? The second comparison. Third one is the C shouldn't be an end of file, right? Those are three different things. And they will be compared and together. One thing is the compiler trying to make your code efficient because here we use those are and signs, means it only works if all three are true, right? So in that case, it's trying to be more efficient. So if it will evaluate from left to right. So the first one, if they evaluate it's a false, it will just skip the rest of it. It will never evaluate the rest of them. Yeah. That's actually very convenient sometimes. For example, if you are reading a string and you want to make sure, well, it could be have two cases. One is the string is empty, right? If it's not empty, you actually want to read the length of it. The length should be smaller than 10, for example. So in that case, you could have those two conditions add together using and sign, right? So even the string is empty, that means your string length function won't work in that case, but because that's the second step, you don't worry about it, right? So as long as it passes the first one, you can have it. But anyway, so yeah, knowing this is more efficient for you to add operator. We have seen that a lot already. So basically, adding a lot of reading, and again, as I mentioned, I provide this template file e3-1.c in our share folder. Trying to open it up, use that for this exercise. All right, in this exercise, we have this for loop. All right, now change it so you're not going to use the and operator anymore, just to break it up into multiple lines. All right, that's the only requirements for this exercise. Let me see if I have any hints here. Yeah, so you will have handle three situations. One is bigger or equal than len -1. It's not end of line. It's not the end of file, right? So those are three conditions. And yeah, so you basically change your loop using if statement instead of having everything in your for loop, using if statement instead. And yeah, to make the change. All right, so please go ahead. So one example, oops, will be like this. All right. So in the for loop, we only compare if I is smaller than this limitation. Note that we have the -1 because we want to save this last character. Then we'll read the character, use getChar, and then we will compare it to the end of line, end of file. If that's the case, we break it. Otherwise, we continue to read this case into the array. All right. So that could be one solution. Obviously, you could have many other ways to do this. Okay, one thing actually I want to point out is the C is obviously saved for getting the character, but the type of the C is actually integer, right? It's not a character.